Hello everybody and welcome to today's very special stream. Hello everybody. So today I am joined by Olga and Marek, and we're here to discuss GoodAI and the General Artificial AI Challenge. So I don't know if you guys want to do any intros here about yourself, or maybe I mean, you would know you guys, but we can just start. Okay, all right. But yeah, that's the plan for tonight then, guys. Because we kind of asked last week. We were saying like who would be interested in doing some AI stuff, and a lot of people were interested to find out what's been going down with the projects over the last couple of months and how they've been developing and progressing. So we've got a number of topics to cover today, and some of that will include answering your questions. So I guess we should get stuck in straight away. So to start with, we're looking at yeah.
Yes, Joel.
So I'm just taking this all in here.
Yeah.
About what you guys wanted to learn about Marek's general AI research and the development company GoodAI. So Marek, let's start with the basics. Let's go to what is general AI.
So the term general AI has been invented to distinguish between narrow AI and general AI. Basically, it should be just the one thing, but the reason why we are talking about general AI is that many of current AI approaches are very narrow. They are focused only on solving very specialized and very narrow problems. The skills that the AI learns cannot be transferred from one problem to another problem, cannot learn cumulatively or gradually. It cannot use what it already knows, how to solve some problem to solving some other problem, and so on. So in other words, basically like the AI that we have today doesn't learn like human, and the general AI is this approach that is supposed to bring us a human level learning capability. So again, narrow AI is what we have today, and general AI is what we should have in the future if we want to have like real intelligence.
Cool, good answer. So I guess the next one is why general AI, but you kind of covered it a little bit there, but any more reason for why general AI?
I can go even more.
In more detail, yeah.
Technical thing, just see, they're posting about the mic.
Technical thing?
Yeah, that they can hear
Hardcore
us very well.
silence.
Mark's a bit low, is he?
No, yeah.
It's normal volume, guys. I'll get it closer to Marek, but yeah, just maybe just go ahead, Marek. Keep an eye on it. I've got everything should be fine.
Mm-hmm.
As it normally is. It's normal level.
Okay, so why general AI? So again, the AI technology that we have today, all these approaches are able to solve only some specialized problems, and basically they will not solve what I want to solve with artificial intelligence or with automating the intelligence. So that's why I'm not that much interested in narrow AI solutions, even though they are good inspiration. There are some useful ideas. And so why AI or general AI? Why is it important for me? It's basically that I see intelligence, like the ability to solve problems, invent new things, discover things, and so on, as a leverage, as a tool that can actually maximize every other tool. So instead of me working on this or that, like space travel or let's say like some medicine or solving diseases and these things, I can work on AI, solve it, and then use it for solving all the other things. And this has been the main goal for me and main reason why I started to be interested in AI, because I really think that humans, we are at the limits of our natural intelligence, and if we want to move it to the next level, we need AI. But at the same moment, it will be somehow just extending. Even this AI will be just extension of our natural intelligence. So this is the reason,
Okay. And what is the mission of GoodAI?
Mhm.
Yeah.
It's to build a human level general AI and then use it for understanding the universe, helping humanity and people, and for scientific discovery, space exploration, and doing all the interesting things. You know, because without AI we can do these things just like we have been doing them for centuries. But with AI we can actually accelerate this process, or we can actually optimize this process and make it more diversified, much accelerating at faster rate, and even this acceleration can be increased and so on. So it's the next level, and yeah.
It's about making AI to discover and for us, basically, right?
Yes, or together with us.
Together with us.
Because for me it's really an extension of our natural intelligence. Like, I don't expect, or I don't want AI to replace us.
No.
I just want to use AI as an extension, just like you're using glasses to see better, or car to drive faster, or like move faster. I think AI can be another thing, like to help you solve much harder problems, more complex problems, or problems when there is so many variables that as a human you will kind of get lost. And but what is more interesting is actually optimization of this process. So with use intelligence to make better intelligence, and then use this intelligence to make better intelligence.
Yeah.
This is what really
like a chain effect.
Chain effect, or it's like some meta thing, you know, like you solve something that solves something that solves something.
Yeah.
And also you can gradually build on top. You build one building block and then use it for building the next building block. So this is.
There was a question. Then Joe, now when you
sorry, I zoomed in to help us read it.
There was about like if Marek is an intelligent machine sent from that came from the future to create.
Marek,
itself,
are you a super intelligent machine sent from the future to ensure your race's creation? Please confirm or deny.
Deny. I'm denying this. I'm still just a human.
We'll have a lot of time for questions. I mean, we'll try and answer some questions throughout the stream, but there'll be if at the time at the end we'll see what we've got left to do some more questions. I don't know, Marek. If you see anything that you like, just go ahead. So I don't know if there's I'll try and highlight them, and but you can choose which ones you want.
So, for example, DC Winnie O today is asking, how do you plan overcoming artificial narrow intelligence to achieve AGI, general AI, without creating a system that would require larger computer systems to process information requests? So there is actually like many ways how to answer these questions, and the thing is that current narrow AI is actually very we call it data inefficient or sample inefficient, which means that it needs a lot of examples to actually form some hypothesis, how to solve some problem, or how to classify something, how to predict something, and so on. And because its learning mechanisms are built this way, you know, like today, when the AI needs to form this hypothesis, it needs to see thousands, sometimes millions of examples in order to form correct hypothesis. It's just like very simple example. Imagine that you were just AI, you were just born, like you were never trained, you know, like you are just born, and someone wants you to categorize pictures of cats and dogs. Like, how would you be able to form hypotheses? You know, like what features, like visual features, you'd be using that this is a cat, this is a dog, or something else. You would need to see certain amount of examples in order to form some hypothesis. If you don't have some prior biases or prior, you know, heuristics that actually narrow this hypothesis search space. And so, so back to the question, narrow AI or the AI mechanism that we have today are usually needing all this huge amount of training data. And on the other side, people, if you look on this from some perspective, can learn from very few examples. Like, of course, we learn from many examples because during your day you can think about every moment like some example that you can learn. So there is definitely a lot of examples, but sometimes we can actually learn from very few examples. So this is just one way how to make general AI faster than the narrow AI. The other is, for example, to actually using your first iterations or prototypes of your AI to build better AI architecture with better properties, better learning algorithms, better adaptation algorithms. So it will be actually getting better at adaptability, and adapting itself to solve some problems. And actually this leads me to maybe important thing. Maybe I should describe what is intelligence or how we define it at GoodAI, and then maybe talk a little bit about some principles. So for us, intelligence, just one definition because there can be many, is that it's a tool for so intelligence.
The questions are distracting.
Yeah, I know, it's hard, isn't it? There's a lot of questions. It's great to see there's tons of questions.
Intelligence for us is a tool for searching for solutions to problems. So we can see this like there is some huge space of possible solutions, hypothetical solutions to problems that you want to solve. Like you want to invent something or just solve some problem, calculate something and so on. And the intelligence is the tool for searching, for generating the hypothesis, testing if these hypotheses are good. And if you go one meta level further, you can actually have intelligence that is actually generating the system that generates the hypothesis and learns. Or another way how to put this is intelligence is a tool for searching for a solution to problems or solving problems, and you can have actually skills that help you to generate another skills or hypothetical skills like candidate skills and so on. So this is very important. Another definition of what we are doing here is that we are actually building system that is adapting itself to solve novel problems, never seen problems. And this is very, very interesting that basically almost any living organism is also adapting itself through some feedback from the environment so that it can survive better or solve some other objective in the environment. And again, with this meta principle, you can look on this that you are actually adapting, or the AI will be adapting itself for even better adaptation to novel problems. Or maybe another way how to put this is that if there is a problem that you have never solved before, you know, like a new task, you don't know how to solve it, and then basically you need to adapt yourself so that you can solve the problem. So this is step one. And step two, or meta step can be if you will be adapting yourself so that you are preparing yourself for better adaptation for future novel and never seen before problems, but problems that you can kind of anticipate. I think it may be kind of confusing, but I will get back to this. But these are the kind of like common sense principles, you know, not very technical, but still very important that we have like through, like from bottom up, top down in our architectures, roadmaps, and in everything that we are doing.
Okay. Would you like to answer another question, or do you want to move on with the things?
Maybe some question.
Okay. There's a lot here. So there's one here that might be good.
So Kienata is asking, what is the baseline? Will it be able to understand later samples it is meant to learn from using earlier examples and cumulative knowledge? Yeah, so it's exactly this. This is why we actually are building architectures, AI architectures, that will have this gradual learning capability. So it's basically being able to accumulate one skill after another. So when it learns how to solve some problem and then it needs to solve some other problem, it will try to reuse some of the existing skills to solve the new problem. And if this will not lead to solving the problem, that it will use these skills to discover a skill that can solve this new problem. So it's, for example, like if you don't know how to cook some food, but you know how to read, you will open a cookbook, start reading, see the recipe, and then you can cook this thing. If you didn't know how to read, you would need to ask some people or maybe invent the recipe from scratch. And this will be much more complex than just reading it from the recipe book. So that's one way how to look on this. So again, like what we are doing is about accumulating skills one after another, and then using learned skills to learn new skills more efficiently. This is very important because the narrow AI usually just learns some skills and then cannot use these skills to discover new skills more efficiently.
I also like to question this one about the some AI is based on flocks of birds, ants, etc. Some real-world models are considered valuable in AI. Have you used any real-world modeling?
I'm thinking how to answer this. I don't know what do they mean by real-world models.
Maybe like inspiration from real-world examples or some from nature. You know, basically.
Maybe not exactly these things, but some parts of this, because you can look on, or like people tend to look on flocks of birds, ants, and all these things like complex systems or complex adaptive systems or multi-agent systems, and so on. And you can try to see how these agents in this scenario, like birds or ants and so on, how they are communicating together, cooperating, maybe competing, in order to achieve some global objective. So each of these ants or birds has some local rules that is like executing. But globally, the entire flock of birds or this entire multi-agent system has some emergent behavior, a behavior that emerges from these behaviors of the local or smaller agents. And there is some kind of decentralization in the system. They are autonomous, usually independent, and so on. So basically, it's like from having these local or micro rules, you can get to these macro rules. And where are we using these? Basically, all the architectures that we are building are using in some way what we call experts. So these experts, you can see it like some neural network or some different kind of agent is also trying to solve some problem, has some input-output, and is communicating with the other experts in the brain of the AI. And they are learning how to communicate, how to cooperate, and so on, in order to solve this global goal, or to minimize error, to maximize reward, or whatever we decide. And this is a big topic actually for us, this multi-agent cooperation, and like whatever you call it, because there is so many subcategories or like sub-levels that are in this thing. So I don't want to say that we are using exactly, for example, ants and all these like there are some actually algorithms that are using the way ants are communicating by spreading the how is it called? This thing that pheromones. Yeah, pheromones. Spreading the pheromones and stuff like that. So there are some like ant optimization, something, I forgot the name. So we don't need to use exactly these things because those are the rules that ants or the nature have invented for their particular problems and their particular environment. Our experts in our AI brain are solving different problems. It's different kind of environment where you have different access to resources, different communication and computation, requirements, and so on. So this is different. But what is same? It's that it's still multi-agent system. There is some communication, cooperation, maybe competition, and many other things. So Joe, can continue.
The next one. This one here?
Which?
Maybe we can.
Yeah,
we either can talk more about intelligence, or we can move on to our.
It's up to you guys.
Yeah.
If you think you can answer that, I guess.
I already talked about it.
Yeah. Okay.
What is intelligence? Then gradual learning, I already kind of mentioned, but I can get back here because I think this is really one of the most important things that we have here.
Okay, yeah, just talk a bit more about gradual learning then.
Yeah. So basically, we have this term, we call it gradual learning, but in literature, it is called different ways or in different names. So some people call it cumulative learning or incremental learning or transfer learning, or I will not remember, but there is like maybe 10 different names. But why we call it gradual learning? Because actually we don't just want the agent to be learning the skills gradually. it's actually also about us, the researchers, developers, building this architecture gradually and basically using one version of the architecture to invent the next level of the architecture. So you can think about like some kind of recursive self-improvement, or some people may call it bootstrapping. It's like, maybe people don't know what bootstrapping means, but it's like if you will try to level up yourself by pulling your like shoe, you know, these shoe ties. Shoelaces. And so again, it's like you build something, and then this something will use itself to discover the next level, and then this new thing will discover the next level, and so on. And why we think this is more efficient than the other approaches, which are relying, for example, on manually, like a human expert composing the architecture with all the topology and stuff, or setting up the parameters, setting up the learning algorithms, and so on. We think that the goal where we are, or the target where we are going, this general AI with millions of learned skills and millions of experts that are communicating with each other. We think that actually it will be impossible for people to engineer this kind of system, because it will be so complex that we'll just get lost. So we actually need to solve this first meta problem, which is like how to build an architecture that will satisfy this criteria. And or maybe another way, it's like how to engineer a process that will lead us to engineering this general AI. It's like if I know that I'm building something which I am with my human brain unable to do because it's too complex, I need to think about ways how to engineer the engineering of this process. So that's why we have this meta learning and so on. And back to this topic, gradual learning. Why we call it gradual learning? Because it's gradually accumulating one property, one skill after another, and basically optimizing itself or improving itself to be a better at adapting. Basically all the way increasing its ability to adapt itself to solve new unseen problems. This is the thing. It's just like the challenge that Olga is running, and we'll get also back to this later.
Yeah.
There is this first round, we call it gradual learning, and there are tasks. There is 40 tasks. They are symbolic, and the agent or the participants should design agents that will learn to solve one task, then another, and so on. And these tasks are designed in a way that some tasks are reusing the skills learned in the previous tasks, or like most of them should be. So if you are solving task number 10, and at the beginning you don't know how to solve it, because it's a new puzzle for you basically. So you don't know exactly like what kind of symbol should you answer. But if you will use your experience on the previous tasks to generate the hypothesis how to solve the next 10th task.
Okay.
So again, you are solving task number 10. And if you will use what you learn in 1 to 9, in a way to bias you, kind of to generate the right hypothesis.
In the 10th one.
Yeah. You will reach the solution faster than if you will be just like go from scratch, or just shooting randomly or something like this. So again, if you are solving task number 10 and you are trying to solve it just by giving random answers, that's the worst way how to solve it. But the better way how to solve it is to basically bias yourself in a positive way, so that you are generating a hypothesis for the solution that were somehow useful in the previous tasks. So it's like basically some way how we are actually looking on this is that as you are learning to solve one task after another, you are biasing yourself in the way you are generating the hypothesis for solutions.
You're using that existing knowledge to create the hypothesis for the next task.
Yes, because you are having higher chances of finding the right solution. That's the point. And because the other choice that you have is just random choice or random luck, shooting the answers, which can, especially for the later tasks like task number 40 and so on, it would take you forever to give the good answer or to give sufficient amount of good answers. And if you want to increase your chances of giving good answer, you should actually use all the gradually acquired skills, this will give you higher chances of achieving good answers, or like a good row of good answers. So
I don't know if you want to. There was something here. There was this one here as well. I don't know if you want to touch
Also,
on any of
the
these
people
ones.
were asking what is happening in the box, which I think maybe they're asking about the screen.
Yes.
So this is one of the first versions of our School for AI that we released, I think, a year ago or so, and it also presents some of our designed curricula for training the agents to develop gradual learning that Marek was talking about. And back then we were experimenting with quite complex, or they're still quite primitive, but more complex environments that we have in the challenge. There you could see this toy world and some kind of 2D game-like environments. And basically we developed this first prototype of the school, which we hope also to develop more, and also invite the community to develop it together with us. I think it is open source, this School for AI. And why school? It's because we have in our roadmap, that Marek might probably talk about also later, in our R&D roadmap we define kind of two important parts of this long journey towards general AI. And first is some kind of an initial DNA kind of algorithm that we need to program with the skill set which will enable the AI to develop further, because as Marek was saying, to program all the skills it's impossible, and to create a complete superhuman AI from scratch, probably it's an impossible or an unimaginable effort for a human. But if we create something which is capable of this gradual learning, meta-learning, as Marek was talking about, these essential skills that allow you to develop these self-improvement abilities, you can then take this kind of baby AI and put it into the right curriculum and let it learn all the human-like biases and useful skills that we as creators of the AI deem as useful. And also there was one question earlier that was asking, isn't there a risk kind of that AI will pick up human biases? And well, probably it will, and it's kind of also what we want. We don't want it to pick the bad biases, but we also have some kind of good biases that help us, survive in this world and accomplish things and so on. So, and also what is important, we want the AI to have a behavior that is kind of similar or that we can imagine. So it's not completely unpredictable, and also an AI which is able to model human desires, human behavior, and can actually understand what we want when we say something like "bring me tea." It understands that you want a cup of tea, a cup with a liquid with it has to be warm.
It has to
probably.
be exactly where I like it.
And
just the right amount of milk.
With milk. Can I show it?
Yeah, you can
See,
show
this
it.
is
yeah.
Joel's tea, right? It's bigger than my head, and there's milk in it.
Yeah, delicious milk.
So and for instance, an AI for Joel should know all those
An
things.
AI for Joel
about Joel.
would know a lot of things about. I feel sorry for the AI for Joel. The AI for Joel would be quite quickly
spoiled by
spoiled.
bad Joel biases.
Yeah.
Yes. So I was talking about this. This School for AI is basically designed to teach the AI the right skills. And I'm not saying that in this particular school that we released there's a perfect curriculum. It's just let's say a test or kind of a first attempt to create a curriculum. And now in the challenge we have a slightly different curriculum, which is very, very minimalistic. It uses a very simplistic environment, which is just a communication environment. There's like command line and environments prints some, let's say, words, and an AI replies something. So it's a kind of a dialogue between this very simple environment and the AI. And the AI needs to kind of understand the patterns that are being given and respond accordingly by only having the only information it has is just some some primitive input from the environment and also a reward or punishment signal, just some kind of indication whether it's going into the right direction or not. So maybe it's time for me to pass over to you, Marek, if you want to add something about the roadmap.
So we've got the architecture and the curriculum to cover, I guess.
Okay, so this road mapping process was very important for us, and because first, before actually starting to work on some specific architectures with some specific requirements and properties, we wanted to make sure that in long run it will be the fastest, most reliable, diversified way how to get there, and so we spent a lot of time actually looking on different architectures, looking on what kind of properties our architecture should have and so on. And so the roadmap is split into two parts. There is this architecture, which is what properties should the agent have. And by these properties, I mean ability to learn in unsupervised way, to learn these patterns in space and in time, to form some short-term and long-term memories, to be able to generate hypotheses, to learn gradually, and so on. And so you can think about this architecture like some kind of network, growing network of experts with some sub-networks and so on. And then the other part is curricula, or we call it School for AI, which is a set of learning tasks where the AI will learn one useful and beneficial skill after another. And what Olga showed you in the video was our first attempt at doing, some learning tasks, but of course they are far from finished or far from being the best, the most optimal or the optimal curricula for our agent. And it was our first attempt. The second attempt is basically what we have in the General AI Challenge, in this Gradual round, which is much better at actually showing the graduality of the tasks, because in this School for AI, it was actually very hard for us to see where the agent is actually reusing some skills in some following tasks, because there wasn't that much reuse visible. And in this Gradual round it's much more visible, and so it's better actually for testing our gradual architectures. But what I'm expecting that at the end the final curricula will actually look different than what we have right now. There will be different environments, different tasks, and so on. And for example, even now, we have some learning tasks that are designed to train the agent not for solving some practical skills like, let's say play a Pong game or something like this, but learning tasks that are helping the agent to actually meta-learn some architecture properties, something like which is internal. Mm-hmm. And like for example, we want agents, these experts to learn to communicate to each other, to cooperate, to achieve some higher level goals. For example, or we want these experts to learn how to have some kind of robustness to failure, like in this network of experts there can be some failure, there can be dropped messages, there can be some experts being kind of lost, or maybe one computer in a cluster will shut down, and these thing should be robust even against these things. Or actually, and this is a big topic and kind of we'll skip there, one thing with recursive self-improvement, and what we are doing here is recursive self-improvement, is that how to ensure that the next iteration of your self-improvement will actually not lead to worsening your adaptability, your ability at recursively self-improving. So think about this, like what if you change yourself in a direction which will prohibit or make it impossible for you to be recursively self-improving. Like one extreme example would be that, for example, right now I would improve myself into thinking that drinking alcohol all day long is the best thing, like it's the best skill. And let's say that I will improve myself in this direction, which will prohibit me for acquiring all the other skills, because I will be just drinking or like taking drugs or something like that. So how to ensure that the AI will not invent something like this, like basically that it will not devolve itself into something that is losing its adaptability abilities. And one way how to do this is actually to have some revert mechanism, something that when you reach a stage where your ability to improve actually decreases, you can revert to previously working solution. Something maybe in the beginning of this chain, in the root, can be hard coded, like in worst case you will just start all over again. And yeah.
So if something goes wrong, you can always like trace it back and try and change that before it happened. Well, before it got to that stage. Yeah. Yeah. I don't know if you just there's something. It's up to you. I'll just throw that there. If not, we can. Or we can. So we covered the curriculum now, haven't we? Then. So it's now. A topic that I'm sure a lot of people are interested in, and this is the AI safety topic. I saw a couple of comments today, not too many. There was I think there was at least one saying about Skynet I saw today. There we go. Hope you don't make Skynet Asylum. So, what's your views on AI safety? Because there's a lot of people out there. Some scientists, like quite leading scientists, have been like, AI is even the death of us, and other scientists are more optimistic, and like yourself, I think, who believe that if it's taught right, then it'll be not a problem. But yeah, so what are your thoughts on that?
Yeah, so there are different risks and then different solutions. Probably nobody can give you 100% guarantee, it's some like mathematical proof or something like this. I think this will be impossible because like we are playing in a field of approximations, only like solutions that are good enough. And now the question is like how good enough, because even the airplane or the car or even the tea with milk that you are drinking, like you don't have 100% guarantee that I didn't put poison there, right?
No, I don't.
You're like some really good.
I only probably have about 90% certain. There's probably about 10% every time I have my tea.
Everybody's making jokes about Joel. So
but again, you're kind of generalizing the tea like for all the years you have lived, and like the chance that someone put their poison is like really small. So you are going to drink it, but you don't have
nothing against Tommy from
100% certainty. And with AI, I think it will be similar, except here the potential like downfall, or how to call it, like the damage, that the AI, like really super intelligence, could do would be so huge that we would need to decrease the chances that it will go the wrong direction, like to really, really smaller percentage. And but I think it will not be like 0%. There will still be some small percentage.
Yeah.
And again, the thing is that, for example, the chance that it will go wrong should be much smaller than the chance that if we don't do nothing, like if we just live the way we are living, that will not end up in a wrong scenario as well. It's like, for example, you can be doing nothing and expecting that things will solve itself somehow, or you can do something, and now the chances you need to balance them in a way that doing the AGI or doing general AI will outweigh these other things. So that's one way how to look on this, or that's one way. And the risks. So to be more specific, for example, if we will have AI that doesn't understand the world in a similar way as we do, this is one problem, or this can be one problem, because this is like this classical example with paperclip maximizer, where you have AI and you tell it make me as many paperclips as possible, and the AI will not understand this objective in the same way as you do, and will start turning everything into paperclips, even you. But in order
I'll be the first to go
to not happen, if you ensure that the AI understands the world in a similar way as you, it will also understand that by you wanting to maximize the amount of paperclips, you don't want to turn yourself into a paperclip. Like it's not in your request, but it's hidden. Like it's somewhere there. And because just like if I tell you, Joe, like give me as many paperclips as possible, I know that you will not starting generalizing in this wrong, like direction and
No.
turning even me into a paper.
No.
So to ensure that the AI understands the world the similar way as we do, and then this value alignment, which is that the AI will have similar values of beneficial or safe values to us. And again, this is similar thing. And so how to solve this, all these risks, and there are many other, is to actually train the AI with right set of learning tasks and basically to bias its behavior in a direction that it will always generate actions that are safe and beneficial to us. So first, we must ensure that it understands the world in the same way as we do, and then that it understands our commands, and then that it knows in what kind of limits it should be moving. So this is it, and it's just like what is our plan actually with this is that to have this school for AI with all these learning tasks, and then there will be some learning task for actually teaching it ethics, and some safe behavior and things like this, where we will show it many examples of behavior that we want from this AI. We'll also show it some like negative behavior and show it like, don't do this.
When you say this, I always imagine that there's some really nice images on the GoodAI website. It's like it's more like a visual representation of it, but it's like AI in a classroom with like a whiteboard with chalk. Obviously it wouldn't look quite like that, but it's when I imagine a school for AI and you're teaching it rules and teaching it morals and that kind of thing.
Yes.
I imagine like, all the little AIs are sat down, they're like looking, and the teachers like telling them what's good and what's bad and stuff like that. So it's got I just added some quite nice images there, and it's sort of a reminder that you guys, if you want to know more detail about anything, definitely check out the GoodAI website, which you can find at goodai.com. There's a lot of stuff on there.
And there was also a question about related to the safety about the hard-coded rules or 3 laws of robotics, and we think that. These problems cannot be easily solved with hard-coded laws of robotics, So, for instance, even our morals and some ethical principles, they cannot be easily mathematically defined or into some hard rule. It's all very context dependent, and people argue about those things for ages, and it's difficult. So, and especially some of the rules, if you hard-code them, they might not apply in the same way in all the situations, and you can actually do even more harm by hard-coding something. And in the future, these limits can be actually counterproductive, because an AI might even come up with some better ways how to, for instance, organize a society, basically help us develop even better morals, or become a better society, better humans. So this is of course quite far away, but it just illustrates that it's probably not as simple as just create a set of rules, and try to think that you have already figured everything out and you're just covering it by rules, right? Because we ourselves do not know sometimes what is right or wrong, so how we can code it into rules. And there was also another question which is also related to this, about what kind of curriculum do you choose and how do you choose it? How do you know it's the best curriculum? And again, it's also very difficult, so probably we say in our team that's going to be probably even a harder effort than algorithmic research or programming the AI to create the right curriculum. It's like with children, you kind of have a best guess what is best for your children, how you teach them the right things, and you try hard and you try different iterations and you see if it worked or not. And probably at the beginning, when you progress, you have some rules or hard-coded safety mechanisms, like you don't let your child go outside, or drive a car or go into some dangerous environment before it's ready for this stage, before it learns the necessary skills. So also with the AI, before we put it into situation or before we allow it to, I don't know, decide about human lives or, for instance, operate some a spaceship full of people, right? Before it can do it, it has to really be ready for this environment. It has to understand the environment that it is being run in, So it's all gradual again. Not only the gradual learning of AI, but our gradual exposure of AI to various training environments.
I just wanted to kind of get in there was just, but then, what do you think about the idea that doesn't it depend actually who's teaching it? Because even with children, children brought up anywhere, like parents have different ideas of how to bring up a child. So probably, I think, for instance, in this AI research community, people have similar ideas and understanding. I guess there's no contradictions, like what AI should or shouldn't learn. For instance, there was also a question whether AI can be easily used in military, as an autonomous weapon and so on. Yeah.
And I don't know. I haven't heard anyone saying that yes, this is a good idea. On the contrary, people are signing documents or saying that they're opposed to this because it's very, we all know what the consequences can be. So I guess.
Yeah. So my point to this would be that when we are talking about safety or ethics or something like this, so first we would teach it, of course, like these basic things like how to learn and so on, and then we would actually teach it how to listen to us and how to do what we want it to do, and so it will not be like a child, that is just doing whatever it wants. So again, we will teach it to be like obliging what we want, or
there's another word I was thinking about, but I won't say it on stream.
Is it a bad word or?
Yeah, come on, it's kind of.
Okay, maybe I my English thing or something like this, but so first teach it to be a good boy or something like that, to listen the other things, because we also don't want the AI to be hard to control, and so again. Learning can be actually seen as a process of accumulating one bias, one skill after another. And one of these skills should be actually ability to listen to us and to do what we want it to do. So this would be one of the first things that I would do to really ensure that it's, when I say no, it really understands no and not like maybe, so I would really make this clear. And then I would show it many examples of some moral dilemmas or situations or whatever, and I don't think just few rules can define what ethics means, because even for people and even for older people there can be situations that are in this gray area of morals. It's like, is it good to kill a person in this situation and this situation? But what if this? What if this? Or very, very simple examples are these trolley problems with cars. That should the self-driving car
kill you?
Kill the passenger, or some people outside, or the old guy, or the young people. Like, how should it decide? Like, who has the lower value or something like this? So this is a tough question.
Because there's a lot of opinions, isn't there? There's a lot of opinions there. Like one, in terms of if you wanted to teach it, some people might do something separate to other people. What you would do, or I would do.
The thing is that I don't even know, if you know what I mean. I don't even know. Like, should it kill me or the people outside? Like, I don't even want to answer this question.
Yeah, in the moment, you don't really know. It's hard to know what you do.
Yes.
Maybe,
yes.
yeah.
And then there can be like different objectives, because some people may prefer, for example, let's use AI to have fun today and don't think about the tomorrow. Some other people will actually want to invest a lot into the future, and they will not try to exploit as much of these short-term things. and so on. So this is another thing. And so again, I think the AI will be building these loose concepts about how it understands the environment, how it understands what we want, how it understands its own goals, or the goals that we kind of like put to it through commands, and so on. And it will not be goals defined with mathematical precision. You know, there will always be some gray area in these things. And our aim is to design curricula that is minimizing all these negative consequences.
Yeah.
Yeah, and basically maybe a good point to this to add is that we want to create the AI to merge with it, so to improve ourselves,
yeah.
you know, to use it as a tool, to use it as some kind of extension,
Like augmented.
of ourselves, exactly, augmented human.
Augmentation. Yeah.
So in the end, we will be those who will be making the decisions, or AI will be helping us to make the decisions, and there will be the border between AI and human will not be so easy
to give ourselves intelligence and knowledge,
and in this
without the AI being in control. Like, if you know what I mean.
We're trying to develop an AI which will not just be another race or another another being, another sentient being which will decide what to do with us, but we want to augment ourselves with AI. We want to create a tool, and this means that basically we will be first. Probably there will be some stage where we will use AI to figure out how to merge with it, right? In this stage where there will be probably some more clear division between AI and humans, but at a certain point it will not matter anymore. So that's a plan. So
cool.
You know, when we will be making the decisions with the help of advanced AI, and we will be the AI kind of. The hope is that more intelligence will help us make better decisions. In this case, it's always better. It seems to me like it's always better to have more intelligence than less when you're making complicated decisions. And I wouldn't be afraid of like some malicious goal of AI overtaking me and so on. But of course, it's not so easy. But that's why we have the curriculum and all the plans how to ensure the safety. So I hope it's clear.
So where we got to here, and I think that's all the stuff about the merging. Would you like to go on to this now?
The challenge I will probably mention just quickly. I'm also curious if there's anyone on the stream now who is taking part in the challenge.
Yeah, just let us know, guys, in chat. Just put anything. Just say hey. Put an 07 or something. Just if anybody has signed up. Signed up to take part in the General AI Challenge.
But by the way, this is Olga.
This is Olga.
And
yeah,
it's also visible
there.
on screen.
she is she's two things. I couldn't fit all her stuff in there. She's the director of the challenge, and she's also the COO of GoodAI as well. But yeah, I chose to put that because I thought it might be more for a challenge.
So the question was if there's anyone who is taking part in the challenge.
Yes, I don't know. There was some people last time. I definitely remember seeing something, but who knows? You never know. There might be people lurking, you know, watching but not chatting. So.
Okay,
but
so
if you're out
for
there.
those lurking and for those who are interested in the challenge started in February and it will end in. August 15th is the deadline, so there's still plenty of time to sign up and start working on the tasks. So we believe it's still like if you enroll now and you haven't done this yet, you still have plenty of time to figure out some interesting solution. And you know, in short, the goal of the challenge is to solve gradual learning, or at least create an agent which is able to solve gradual learning kind of tasks in a simple environment. So it's the first step, right? Then we can test it in more difficult environments, and there will be more rounds of the General AI Challenge where we will encourage people to develop more and more advanced AI agents. But let's say this first round is kind of a warm-up, so there we have a very simplistic environment, so you can, like, you have a lot of advantage now if you start now, you know, and you can go to this website. You can show it maybe, Joel, on the background if it's possible. It's www.generalaichallenge.org.
I've linked it in the chat with them.
Or you can drop it in the chat. Yeah, thank you.
I'll link it again, so yeah, you can check it out.
Yeah, and there you will find all the info.
There we go.
What you need to do in order to start, and you can win nice prizes. There's a prize fund of $50,000 for this round, and the overall prize fund for the challenge is $5 million. So there's going to be many rounds.
Many rounds.
Yes, and not only about programming AI agents, but also about solving some theoretical kind of problems, or maybe designing curricula for the agents, you know, solving some AI ethics, AI safety problems, different cooperation kind of problems between AI researchers, maybe some game theory kind of tasks for you guys. So there's more to come.
It's interesting here. I will ask in the Keen forums for partners to see if there is an interest. Professional programmer, 27 years.
Yes.
We actually have a thread. Let me see if I can find it for you. There's actually a thread there, Heron, on our forums. I need to remember where it was posted. Do you know where it was posted? Oh, it was in, I remember now, I think.
We will be really happy if there are more people from the gaming community taking part in the challenge. Right now we have over 360 participants. Most of them are individuals, because I think it's quite hard for people to find someone to join the team. You know, it's easier just to enroll as an individual. Maybe the task doesn't seem so tedious, so people want to also try it on their own. You know, and why gaming? Because, you know, Marek has a gaming background, and he's doing AI, so I guess the skill set is the right kind of skill set for this type of problem. Yeah.
I think game developers or programmers have some kind of advantage if they understand the theory behind intelligence and AI and all these things. Because like when you develop games, you get used to designing some complex systems, and you basically are constantly doing some kind of research and turning it into development and engineering and some real product every day. And also, if you are doing some complex game with rendering, physics and many other things, you need to be optimizing it, and sometimes even start with optimized version. So I think game developers or people with game development background are a good profile for doing AI, not just for this challenge, but for any kind of AI.
I was thinking, what would you say to people? Because there's a couple of people who want to take part, but they don't have any programming skills. Is there a place? I guess within a team.
Within a team,
Within a team, you know, if there's can be a researcher within a team. So that's worth pointing out. If you can find a programmer to team up with, or a group of people, then you don't necessarily need programming knowledge to just a passion for AI, really, and an interest.
The diversity in the team can be actually an advantage, and there are two categories where you can win in this first round of the challenge. So the overall $50,000 prize fund, $50,000 prize fund is divided into like chunks, and in subjective category, which is kind of a best idea category, you can there's first, second and third place, and if I'm not mistaken it's $10,000, $7,000 and $3,000. And then there is this objective category where people will be actually submitting the code, and you know the code of your AI agent will be run against the set of testing tasks that we prepare, and it should pass them. And there's this prizes of first place is $15,000, then $10,000, and then $5,000. And people can also win in multiple categories and multiple prizes. We will see what kind of solutions we get. And so this best idea, this qualitative or subjective kind of prize, Doesn't necessarily have to be a code, so you can also submit a white paper. On our challenge website there is a specification of what should this white paper include. It really should be structured. So we actually, because if we receive a lot of them, we will never get to evaluating all of them properly because it would be just too much. And we already have over 300 participants, so I assume like there's going to be a lot of submissions. So you can even submit your idea without the code. But of course, like having the code there it's more interesting, but there's a chance for you to.
I just link the forum here as well because there's
yes.
Because this can be a way to, for people wanting to form.
You're showing it right on.
I know I've linked it 3 times here. Heron is off, is saying to Gecko, I'd welcome you to a team, good way to learn. And he's saying no programming skills, they can join me. So Heron of Alexandria,
very nice. Yeah.
Sounds like he wants to form his own team. So if you checked out that discourse, the forum page there, Heron, you might be able to set up something over there. Or on the Keen forums. Maybe you can create a thread on the Keen forums, Heron, like a new thread or something. That'd be cool. Now let's go back to.
We also had a webinar about the challenge recently with London TensorFlow community, and it's somewhere on YouTube, so people can watch it to find out more about the tasks. And there's also an example architecture.
Is it on the challenge YouTube?
Should be linked there. And if you guys Google the General AI challenge and look on our YouTube, there are some lectures or some presentations where you can see examples of tasks and learn more about what you will be solving.
Which one is it? Which one is it, Olga? Do you know which one?
It's probably not here.
It's not on there, okay.
But we can post it later then.
The best thing is if you go to the main website, guys, all the links to all the various social media stuff's over there. What do you do, Olga?
I'll just Google it while you're talking.
Okay, cool. All right. So you can check out this webinar here, guys. There you go. Awesome. So it looks like Gecko and Heron have teamed up. So we've managed to get a team together tonight.
Very nice. Good.
If you guys have got any questions about the challenge, feel free to drop them in the chat. But would you like to? Do you want to add anything to the challenge stuff?
Yeah, I can add that we are gonna have. So basically, the challenge is set to run for multiple years, and we started it because we wanted to scale up our research process. So it's kind of a citizen science approach to developing general AI. We basically in our team we're solving the same problems that we will be outsourcing through the challenge or crowdsourcing through the challenge, and we want to kind of invite the whole world to join and try to solve it, because it's one of the biggest, probably the most exciting challenges. General AI is one of the most exciting challenges, one of the most exciting milestones in front of humanity right now. And in this challenge we're going to have many rounds, as I mentioned, with different AI or general AI related research problems, and maybe end of this year or maybe like start of 2018 we will launch another round. Now we are preparing a round which is dedicated to AI safety. And in particular it will be dedicated or focused on solving so-called AI race problem, and AI race in a sense that there's a certain fear or some prediction that at a certain point AI researchers and developers might end up in a race because of the advantage of being the first one who develops general AI is apparently very, very high. So someone who will be the first might have a very big very big advantage on the market, and the others might never catch up with him or with this group. And this might lead, if this scenario, if this idea is true, this might lead to this race where people will try to develop AI as fast as possible, but they will sacrifice some safety, basically ensuring the safety of AI, just to be first as soon as possible. And for instance, we in our group, we don't want to do that. We want to really ensure that our AI is not harmful. Otherwise, there will be no point of creating it.
Yeah.
But we want to launch a round in the challenge, which will ask participants or anyone around the world to actually look into this problem and propose some solution. It's going to be a difficult task, I guess, but I don't see a better way than just to try and try and go solve it, you know. And try until we do it, and iterate, you know. And I think there can be nice ideas stemming from this.
There's a couple of, and there's also, I mean, just in case you guys didn't know from the last time, there's a couple of interesting a number of interesting sponsors on board as well, isn't there?
Yes, there was actually some people were asking if we are sponsored by NVIDIA, which we are not. GoodAI is self-funded by Marek entirely, at this moment at least. So, but NVIDIA supports the challenge. They're providing a prize. There will be a special prize from NVIDIA, some high-end GPU from them. Still like kind of a secret, which kind or for which, in which category will it be awarded, but there will be this prize. And we also have an NVIDIA member on our challenge advisory board, so it's really cool to have them there.
Okay then, so just because time is going on, guys, I don't know if it's up to you.
Mm-hmm.
Do you want to touch on this, Marek?
Okay.
So let's so Marek, tell us about the AI Roadmap Institute, and I will change the background image here as well.
We started the AI Roadmap Institute a couple months ago, and the goal here was that to continue in the work that we have done on road mapping internally. So the Roadmap Institute is led by one of our colleagues, and the Roadmap Institute is organizing workshops where AI researchers meet and discuss various roadmaps to general AI or to AI and so on, and then compare these roadmaps and try to analyze which roadmap may have some dead ends or some white spaces, white blank areas that are not covered in the roadmap and so on. So again, basically the main reason is that when we were doing our roadmaps, we also wanted to compare our roadmap with some other people roadmaps to see if our roadmap is better or like whose roadmap is better. but the thing is that if there is some better way how to solve some part of the path on the roadmap, then I want to know about this and use that shorter path. And the Roadmap Institute is dealing with these architecture roadmaps, curricular roadmaps, but also safety or futuristic roadmaps, that are more about the social changes or political changes and impact on business and the future, like at all. So this is AI Roadmap Institute, comparing, studying different AI roadmaps, and I think it's very interesting, and we are continuing in this effort even internally. We have actually what we call internal institute, and once in a month we meet and we discuss the roadmaps of our architecture teams and see how they are progressing on the roadmap, discussing whether there is not a faster way how to solve some obstacle or how to solve some part of their architecture and so on. Joel, we can go to the next thing.
Okay, all right. So the next one it's interesting because of course it's more relatable, I guess, to the things we normally talk about on this channel, and that is what Marek is one of the Marek things is a game An AI game. So I'm just kind of, that was my words scrambled there. I don't know what's going on. I'm just tired. What can I say? Sorry.
More tea.
So what was that? More tea required. Yeah. So Marek, tell us about this AI game that you're cooking up.
Not really cooking up
Okay.
at this moment. It's still just
Honestly.
just an idea or something like this. And so again, because we are developing AI, and these AIs are usually trained in some virtual environments, which you can think of like games, it's also a good idea to actually make a game where player will be a teacher and will be teaching the AI by communicating, maybe reward, punishment, maybe supervision, or puppet learning, showing what to do, how to do, and so on. And the AI will learn from this teacher how to solve some problems in the environments and how to learn gradually to use learned skills to solve some other skills and learn more skills and so on. So this is something which we are not developing yet, but I think it looks like one of the best use cases for one of our architectures that we are building here. But in order to do this, we actually will really need architecture that can learn gradually, and then we will need to teach it some set of basic skills, and only then people will come in and start teaching this AI. Otherwise, it will not be fun. Like, for example, if we use today AI, like current AI, narrow AI for teaching, then players will need to show the AI, for example, thousands of times how to do something, and the AI will probably not be able to learn gradually, so we can forget all the time, and it will not be able to form more complex skills or merge together multiple skills and so on. So it will not be so much fun. So that's why we actually first need to develop some gradual architecture and then teach it something, and then we can make that game. So this is still like very early
stuff. Yeah.
Very early stuff. Yeah.
Just
very
just
interesting.
thoughts.
Yeah.
Definitely interesting.
Because it can be like a new
experience,
new kind of genre in gaming. That I know that there were some games where players can teach AI, but the intelligence that was there was very simple, and therefore even the emergent behavior of these AIs was limited. And here I'm talking about like next level stuff. So next.
So the next thing we wanted this stuff, but I don't know which of this you want to cover, or if you want to do some more questions. We have some questions for a little bit. It's up to you though. Which one of these you want to?
Maybe a few questions.
Okay.
And then, because it's time.
Yes, time's going on.
So Orange Immortal is asking, Marek, neural networks AI can learn. So in our architectures, there are two groups that are using neural networks, or at least some networks of neural networks, and then there are two other groups that are not using neural networks per se. They are using some different kind of networks with different kind of rules and logic, in the elements of this network. Because neural network can be just one of the approaches. It doesn't have to be the only one. And actually, if this idea with gradual and guided meta learning that we are pushing here will prove to be good, then this system will actually invent new ways how to learn, how to adapt, how to improve, how to grow. And it will be even for us kind of hard to interpret what are the properties of this system, because it will be very complex. It will be just like you cannot just look on some cells of your body and tell what they are doing. It's very complex. There are too many interacting elements. So again, if we will have this kind of system that is recursively improving itself, it may be using something like neural networks or something different, or it will use different learning mechanisms than what we have currently in neural networks and deep learning, or it will use completely different learning mechanisms. This is really something that we just are going towards, and I'm really curious how this will end up. So maybe some other question.
Yeah, any question you have about anything we've discussed tonight? We have covered a lot of topics. Just to again, just flick over. We mainly discussed the general stuff about AI. What is it? Why? The mission here at GoodAI. The challenge we discussed the roadmap, AI safety, and the challenge and the AI Institute, and the AI game. So all these things you can ask about.
So for example, Can G4 has a question, when AI learns something, how it stores that knowledge? Can another AI get knowledge of that AI to increase knowledge base, like sharing it? So this is a good question. Actually, it's like how to represent the knowledge and how to store it, how to represent it, how to use it, and so on. So neural networks do it in a way that you have some network of neurons, and the signal is propagated through this network in one direction, and then in the other direction you are propagating error and changing some parameters in the neurons and in the connections, and this is what we call learning. And you can have many different ways how to learn and how to represent this knowledge. This, what I just described, is some kind of procedural, because basically the network is executing something, and while doing this, it's actually, let's say, interpreting the knowledge in some way. But there can be different ways. And now to the second part of the question, like if one AI can share the knowledge with some other AI or learn from other. Actually, I think this is very, very important question and topic. And there are, like, again, multiple levels why I think this is a good question. So first, depending on which scale you are looking at, even one neuron using another neuron is some kind of multi-agent system. So you can think about your brain like a multi-agent system made of 100 billion neurons. Or you can think about like a multi-agent system made of, like, I don't know how many molecules are there in the brain. Or you can look at it like a multi-agent made of just few brain centers and so on. So they are communicating to each other, and some parts are learning from the other parts. And neuroscientists will maybe be able to tell you like which part is learning from which one, but I still think people don't know this exactly. So another part to your another answer to your question is also that learning from someone else is actually a smart way how to adapt to some problem, or how to learn to solve some problem. Because if you have to invent the solution yourself, it will probably take you much longer than if you learn from someone else, if you transfer the knowledge from someone else. So this is also another important aspect. And what else can be said here? Yeah, so now the question is like how one AI, and by AI I mean like independent system or part of the network that is communicating with some other part, so they are connected, how they can transfer the knowledge. So again, the question is communication. And if you have this multi-agent system, it's about the communication or the messages they are sending to each other. So they should learn how to communicate the transfer of the knowledge between each other. This is the thing. And how to do this, that's the hard part, of course. But the basic description is that one AI or expert or agent or whatever will learn how to communicate some knowledge from someone else. And we people, we usually transfer knowledge by exchanging words and sentences and all these things. But of course, it can be done on different levels. Like you can transfer the knowledge by exchanging books or drawings or like body language, or like there can be different ways how to communicate. Okay, some other question.
Questions. There was definitely some questions earlier that we missed. Yeah. And I think I just saw that DC Venue returns. I know you might have had some questions earlier, DC. Any questions, guys, from if you are just joining us again?
So Ventus Prime is asking how much hard disk will eat up the AI when it's learning. It's a good question. And like how much memory? I don't know exactly for now. Like, to be honest, I really don't know. Like, one of the systems that we are designing here, developing here, is a system that is made of these experts. It can grow basically without any limit. Of course, then the communication overhead will increase. But again, there can be some other parts of the network or of the agent that will focus on optimize just for making the communication more efficient. And this system would be growing, and therefore even this hard drive space would be growing, and the memory would be growing, and so on. But this was a good point, because actually one aspect of intelligence that we didn't talk about today at all is limited resources. It's like if you are solving some problem and you are not talking about that you are constricted by resources, like computation
when you're
time
doing your stuff,
or memory. Like, you should be talking about this kind of stuff, because you don't have infinite computation, infinite memory to solve these things. There are actually some theories about artificial intelligence or some designs for some AI that are assuming that you have infinite computation, and with this infinite computation you can have general artificial intelligence even today. Except the problem is that no one has computer that has infinite computation and infinite memory. So back to earth or down to earth. We need to really consider limited resources as one of the important things. And so again, and maybe I should have said this when I was talking about definition of intelligence. The thing is that intelligence is a tool for searching for solutions to problems when you have bounded resources. And like, you don't have infinite resources, you have certain amount of resources, and you must invest them in a way that is increasing your chances of discovering the solution, like, the likelihood of discovering the solution. And so one way how to look on this is look on this from the economy perspective, or something like investing. That you have certain memory at your disposal, and also certain computation, certain time, and within this time you must find a solution, otherwise like you lost, and you must invest your resources, your computation, your hypothesis search in directions that are increasing your chances of discovering the solution. So basically this huge search space that you need to search through while looking for the solution, you need to narrow it, so you don't, because you cannot search the entire space, because that is impossible, so you need to narrow it. You also need to diversify your search so that you are looking on the more promising areas. You are looking for the more promising, and diversify so that you don't put all the eggs into one basket. Like, you will be looking for multiple possible solutions. And so resources are very, very important. But what is so funny?
Oh, it was just
the comments about making a Terminator
making me a Terminator. I don't know.
Stuff like that.
Marek is planning on making the Terminator's boss. There was a couple of questions, Marek. There was this one, but there's actually quite a lot coming in now, so you can choose.
So, does AI already have notion of unclear, or it only operates on success, failure?
It's like black and, is it as clear as black and white for? I think for a
This is more complex question, but the thing is that there are some AI algorithms, like for example reinforcement learning, or some like picture like visual recognition things, where you have certain certainty, or you have some certainty of how sure the AI is about its decision. So for example, when the AI is classifying some image and saying like there is dog, there is cat, it will tell you this with certain number, like it will be on a scale from 0 to 1. So it can say like, okay, I'm 100% sure there is a dog, and I'm like my confidence in saying that there is a dog or cat is 0, and so on. So there is this thing.
Okay.
But I would say this is very simple level of confidence, and actually I think what is more important or interesting is when the AI will have its own abstract concept of confidence, and then will be using this to make its decision, set goals or sub goals, and so on. So I'm not saying about some mathematical function that is telling you good or wrong, but actually about some abstract concept that is telling you this is good, this is wrong, or my certainty is this or that, and so on. So and the uncertainty actually I think is very important, because when I was talking that we have limited resources, limited time, limited memory, you are always going to end up with solutions that are just approximations, like they are just the best possible under certain assumptions, certain resource constraints, and you will never have 100% solution, so we will always have these approximations. But another part of this question actually I think is important, that I would consider actually a criteria for success if it goes above certain threshold. You know, like sometimes you don't care if you are doing something on 100% or 90%.
Yeah.
Like unless you are doing it above, let's say 80%, it's good, you know. So just like in this gradual challenge, we have this criteria actually for evaluating the agent, that as the agent is learning to solve the tasks, we don't really care how efficient or how good the agent is solving the task. Like it can make some mistakes, but there is this thing that it must be successful enough. Or Olga, maybe you remember like how we define this.
Not ratio of, like, it's like how much you can. You're okay to have a little bit of
like basically
failure,
we are not accumulating all the good answers that the AI will give us and tell like, okay, this AI has better performance than this AI because it's winning in more cases or something like this. Like we don't really care about this. The AI just need to go above certain threshold.
Not the
being
score,
successful.
basically. Not some like.
It's like successful enough, basically, and then we stop counting. So the AI that can solve something with better score than some other AI is equally good for us, and the only parameter that we are looking at is how fast, how many time steps did it take to discover that solution. But then we don't care about how good that solution is when compared to something else. This was very important for us because we are like the aim of our goal of our project is to build AI that is actually fast at adapting itself or learning. We don't really care how good it solves the solution. If they are solved it like good enough, or like, I forgot this word, but it was really nice, like
acceptable.
I think it's acceptable. Yeah, I think it's acceptable. Like if the performance is acceptable, but I know that it may sound like some weak
like
thing.
Good enough to start solving another task. In the next
it's
task.
like, let's say that you are playing a game, and if you are not like a pro gamer or something like this, good enough or like acceptable performance, your performance on the game is acceptable if you are able to progress in that game. And you don't care if you are like killing everyone, you know, like headshots and stuff like that. So this is this stuff. So again, what we care in this challenge is how fast is the agent at being able to solve the new problems, the problems it never encountered before. This is what is important for us, not what is the performance or the score or the reward or whatever of the agent on those tasks. This is very important.
Yeah, so basically not optimizing for performance, but for ability to solve new problems.
Yes.
Okay.
So what else?
Well, there's this thing which is this the main question is, I don't know if did you answer this one or am I going crazy?
No.
The question is, that's the main part of it. I can look at something else.
So, I will try to answer this question. First, I will try to say it in my own words. It's like who is saying what constitutes the solution of a task.
Yes.
So, in our challenge is us who design the tasks. So each task, how is design a task? A task is there is environment that is generating some symbols. and then the agent is trying to answer, to give some responses, and then the environment measures if these answers were good or bad. Like in some puzzle game, you can like really see how this can work. That there is environment generating the questions, agent is giving the answers, and the environment is telling like good or not. So it's really clear here, like who says this is a good enough solution or this is not. And this is, I think, good enough for now, but in the future, I think the goals of the AI, even sub-goals, will be much more conceptual and less clear. They will not be communicated through reward and punishment like we have it now, but through communication, natural language communication or some communication, because it's also like much more efficient way how to communicate like in both directions. And now who says like this is a good solution or this is a good direction of actually evolving yourself? The thing is that we people, we have some biases, or we are biased in certain way by evolution, by our DNA, by our society, by our individuality and all these things. And we want to transfer this kind of biases or values, let's call it values, to these AI systems, and then together with them continue and evolve these values. And so I think the AI will never have complete freedom in determining what it wants to do, because it will always be biased by these prior values that we will put there. And we are also biased by the prior values that were put on us, by evolution, by society, by family, and all these things. So yeah. Yeah, it's something like instincts, these values, but some other values I think will be much more abstract. It's just like, for example, if you have a value that someone wants his children to live, a good life, okay, you can say that this is an instinct, even though it's hard to say like how this instinct is transferred through DNA to neurons and so on. Or there can be another value, like for example, someone wants to paint nice painting, and this is his value, that he just wants to be painting nice paintings. And there are some parts that you can say this is instinct, like maybe he just wants to create stuff, explore, discover and so on, but some other are very, very abstract. Yeah. I think this is really good question, but also very hard to
yeah
answer.
Definitely.
Yeah, and also very hard to actually like pass how I mean it, because these things are very, very confusing.
It's hard to put into words.
Yeah, hard to put into words, and because
you've thought about it a lot, haven't you?
Yes. But it's a problem with definition, because like when we are communicating, we are sharing the knowledge by exchanging words, and each word has some meaning to each of us. Usually, or most cases, we have pretty much the same understanding of the words, but sometimes not, and this is where the confusion can come in. So this is very hard. Like from my experience, I know that even in our team with guys that we are working for years and every day working on these things, even there can be a lot of misunderstanding on certain topics. And by misunderstanding, I mean not like we have different opinions, but everyone sees it from slightly different angle.
There was a word earlier, just thinking back to the last point, was the word you're looking for proficiency? Like you were talking about like the ability, what's acceptable, I think.
No, like
the proficiency.
like the.
Sorry to get back to that
I
one.
guess the opposite of proficiency, because proficiency is kind of like, to me it sounds like perfection in something,
Okay.
And that's not necessarily like in order to move on to next tasks, you don't always need to be a master, a professional, or proficient at this previous thing,
Mm-hmm.
So
maybe one last question.
Okay.
Because we can always do this in the future.
Definitely.
So Christopher is asking, wouldn't the AI evolve to not use these values at a later stage, because it's gonna optimize itself. So I think this is a good point, and I think if these values will be designed and learned in a good way, then it will have values that it doesn't want to overcome these values, if you know what I mean. It's just like, for example, my current values prohibit me killing people, that I just don't want to kill people, and I also don't want to like alter my brain, you know, like to start playing with my brain and to change myself into wanting to kill people.
No.
Because I don't want this thing, then I'm also not going to evolve myself into wanting to kill people. I know that this is kind of like crazy example, but like, you know, easy to understand.
Yeah.
And so I think this will be the same scenario. The problem is, of course, if there will be misalignment on the understanding or on these values and so on. Like that's obviously there can be error, you know. That's one thing. But there is also like a different side of this problem, and it's like if this AI will be recursively self-improving itself, we may not be sure in which direction it will actually evolve itself after many iterations. You know, because it's a complex system, it's an adaptive system, so it's a system where it's very hard to predict how the next step will look like, and even much harder how the next level will look like, and then next, and so on. So, like for example, I cannot predict how the human society will look in 10 years, nor can I in 100 years or billion years or something like this. It's just like if people in some Neanderthals, if they would be predicting 21st century, and they will be like, okay, people will be using internet, mobile phones, and Twitch, and all these things. Like, of course, it was impossible for them to predict.
To conceive that, even.
Because they couldn't just take linearly and just expand what they had. Like, okay, so they will have probably more fire. They will have probably bigger caves.
Yes,
it's
true.
That would be their prediction. But like the real prediction would, if you start putting these things on top of each other, like this exponential, gradual thing, and it wasn't possible. You just need to like simulate those things through. It's that kind of systems, complex adaptive systems, that you can have a mathematical formula that can help you predict the next iteration. You actually need to simulate through it. And if it is something as complex as human society or as complex as AI, you will have to simulate that system. So for this reason, for example, we don't really want to develop super intelligence in the first stage. We actually would be very happy if we have something that is human level AI, helping us to augment ourselves, and then actually self-improving ourselves to the next level, because then it would be improvement of the AI, but also improvement of us, so we will feel more confident in this, in this scenario. Again, like how we will look after, I don't know, like 100 or 1,000 iterations. I don't know, maybe like the me, what I consider to be me, my values, my memories. Maybe it will be like a super small part of this new entity, because it's just like my like 3-year-old Marek is probably still somehow inside me. Like there are probably maybe like
somewhere
one or two memories, but that's it. Like, there is so much more of the new Marek that is there, that this small Marek or little Marek is just like, how to say this, like very small part of me. And again, I also don't feel like this little Marek is dead or something like this, but again, it's illusion, all these things. But again, if we value these illusions, that we have this continuity of ourselves, of our identity, and for some reason it's important for us, then it's good to think about how we can maintain this continuity, and how we can maintain this continuity of this illusion that it's actually us who is self-improving and not some alien AI system, that is self-improving itself, but we are not. So yeah. So that's it, Joe.
Cool.
Yeah.
All right.
By the way, guys, I'm really happy for all these questions. I think it's really like people are interested in this topic.
Yeah, it's true. I mean, we asked last week, and just put down an 07 in the chat, guys. If you would like to see more of these streams, covering GoodAI and the challenge and everything related to it in the future. We'll probably do them anyway, whatever you say. But we'll probably force it upon you anyway.
Joel, maybe one question. There is this, because I really like this, from XCanG4. So he's asking if the AI may being...
This August from here.
Okay, so basically if the AI can do something like self-programming, if it can be writing its own code like programmers are doing and so on. So this something like this is actually what we are doing in one of our architectures, that we actually created or are creating some kind of programming language that the AI is then using to self-improve itself. And this language is not as complex as the other programming languages that we are using, like C++ or C# or something like this. It's much more simpler, but that's actually a good thing because we are limiting the search space for the AI when it's improving itself, when it's reprogramming itself. Even though it's not like a programming language, you know, with words and symbols and all these things. It's more like a network of experts, and which is interpreting the code or the programs that are there. So yeah, this is an interesting question. I think very, very important for us with like this gradual guided meta learning approach. Yeah.
Yeah.
Yeah. Oh yeah.
Have you got anything you want to add, Olga, before any closing comments?
Join the challenge.
Join the challenge, everybody. You know, where to find it. Again, I got some people who joined us late. You can find the challenge there, the Roma Institute there, and yeah, they're the main ones that are worth checking out there. And of course, the GoodAI website, which is goodai.com. But lots of people would like to see one of these again. So that's great. That's great to see that, guys. And I'm glad you've enjoyed tonight. And there'll be definitely more opportunities for more questions in the coming weeks and months.
So thank you.
Thank you.
Thank you.
Yeah.
Yes.
So
Thank you for good questions. Goodbye.
Bye.
Our mission is to develop general artificial intelligence, being helpful to humanity, and understand the universe. GoodAI, being helpful to humanity, and understand the universe. Our mission is to develop general artificial intelligence. General artificial intelligence. Being helpful to humanity.